Okay, students, here's our last section of Module 1, Centroids. We're going to first review, because centroid, as you see right here, is part of the main 4 types of points of concurrency. Remember we talked about points of concurrency before. Talking about the circumcenter is where the 3 perpendicular bisectors of each side intersect. Okay, so here's over here, this is the perpendicular bisector of this side, this is the perpendicular bisector of this side, and this is the perpendicular bisector of this side. So it's point P is the point of concurrency there. You know, I put my compass pointer here, a pencil on one of these vertices, as it shows here, all of them will be equidistant away, and I can draw a circle around that triangle, so it's called the circumcenter. Okay, that's what that center, that's what that point of concurrency will create, a circle about the triangle or around the triangle. Then we did angle bisectors also back in the construction days, where we took the angle bisector of each angle and where they intersect. Each one of these 3 is an angle bisector. They intersect right there. That point then is equidistant from each side. That side, that side, and that side. That's why I saw these. That's why you see these 3 the same length, which means I can draw. If I put my pointer here, my pencil right here, I'll draw a circle perfectly right inside of here, and touch each side once, and that's called the incenter. So that comes from the 3 angle bisectors. This is the one we're talking about today. And then we also had an orthocenter that we didn't end up doing, but that's the 4th one. Orthocenter is from drawing an altitude. An altitude goes from the vertex to the perpendicular of the opposite side. So here are the 3, and you technically only have to do 2. They'll intersect in the same spot for any of these. So here's a perpendicular an altitude, here's an altitude, and here's an altitude. Don't forget, another word for altitude is height. Okay, you gotta remember that. Altitude and height, same thing, because height goes from the vertex to the perpendicular of the opposite side. Always has to be at 90 degrees. You gotta see that perpendicular symbol. Um, and that is called the orthocenter, just so you know. So today we're focused on the centroid. The centroid is when we have 2 or 3 medians. These are called medians. Median goes from each vertex to the midpoint of the opposite side. Remember, we talked about midpoints with our mid-segment theorem and our medians that we just did on your homework, your last homework assignment here. So here are the 3 medians. This point is the midpoint of BC. This point is the midpoint of AB, and D is the midpoint of AC. Where they intersect is called the centroid. Okay, that is actually where the triangle is balanced. If you're to balance it, put it like a teetering piece on it. That's the piece that balances the entire triangle, if you want to think of it that way. Okay, so it says the centroid of a triangle is 2/3 the distance from the vertex to the midpoint of the opposite side. Much easier than remembering all of this is if you just go ahead and remember the ratio. 2x is from A to R, and x is from R to the midpoint of the opposite side. We'll call this point F here. They didn't put a point there. Put that in there right there. So from R to F is x, and from A to R, the centroid is 2x. So again, from the vertex to the centroid is double the length as it is from the centroid to the midpoint of the opposite side. 2-to-1 ratio. So obviously the total length would be 3 x's. I'd divide this into 3 pieces. First piece goes here, the next 2 pieces is this distance. This is what we'll begin working on talking about today. And remember, this is the midpoint. So again, this distance equals this distance. So if I know FC, I would double it to get BC. Or if I know BF and they want BC, I just double it. Or if I'm given this BF as an algebraic expression and this is an algebraic expression, I set them equal to each other and solve because they're equal. Okay, that would be dealing with this side of the median, but a main thing is understanding these relationships and having this memorized. Okay, so that's what we're focused on here. I just threw this in here at all, just so you know, with orthocenters, this last one you do the altitude. If you start with the right triangle, the orthocenter is actually right at the right angle itself. It's on the triangle at the right angle. If you have an acute triangle, the orthocenter will be inside the triangle, and if you have an obtuse triangle, see this is greater than 90 degrees, then the orthocenter, when you do the three altitudes, or two is really all you need, the orthocenter will be outside the triangle. I pointed out just because I can't remember for sure if I saw that as a question on the GCAS in the past, and so I'll make sure at least you're exposed to it. Some of you will remember it and some won't, but just in case it's on there, I'm not going to quiz you on that itself. You'll be getting quizzed on knowing these centroid, knowing these distances, any of these particular ones. So from C to R's, if you want to call it 2y, and then from R to this midpoint is y. 2-to-1 ratio. This is always double the shorter. Obviously, you can see this is longer from the vertex to that, and this is the shorter piece. So just got to remember, it's 2-to-1 every time, 2-to-1. Okay. All right. So now let's go ahead and look at some problems here. It says find the length. Remember, that means distance for the length of LJ. So once this piece, these are all medians. These segments drawn are all medians, just so you know. It says it in the direction on your assignment. These are actually 3 problems right from your homework itself. Okay. I redraw that again right over here. So you see a 2x to x ratio to your 2-to-1, or it could be 2y to y, same thing, 2-to-1 relationship. Okay. And that's what that is explaining right down here, as I just talked about on the last page. Okay, it says find LJ if IJ is 6. Well, if the whole thing is 6, remember if it's the whole thing, we put it right here in the middle. That point is, if the whole thing is 6, then obviously LJ, since this goes to the midpoint of the side, and therefore these two lengths have to be equal, then obviously LJ is 3. Very simple. So LJ 3. Okay, that's as easy as you can get right there. It says find EZ. EZ, remember the relationship is 2-to-1. If ZW is 12, let's say ZW, ZV is 12, I meant. Okay, so ZV is 12. Remember, this shorter piece is half of the longer one. So that's half of the longer piece, and the longer piece is 24. Double it. Remember, it's a 1-to-2 relationship, or you can say 2-to-1 if you go this direction. 1-to-2 in this direction, or 2-to-1 in this direction. Okay, so there's our answer, easy. 24. Again, easy because it's only numbers, not algebraic expressions yet. Okay, now we'll go ahead and throw in with algebraic expressions. All right, it says JW is 6x plus 2. So that's right there. JB, the entire length is 10x plus 1. Okay, well, remember down here, the entire length equals 3 x's, 2x plus 1x, 3 pieces. Okay, this length from JW is 2/3. Remember, this is 2x to 1x, so this is 2/3 of the whole distance. So if I do that, I would be saying 2 divided by 3, 2/3 of the whole distance. What's the whole distance? JB is the whole distance of 10x plus 1 equals JW, 6x plus 2. Now, I'm not going to go ahead and distribute this fraction. So right here, I'm going to be smarter. I'm going to multiply both sides by 3. Okay, remember, since there's more than one term here, we'll make sure you put parentheses around it. So I distribute it through. So I'm just multiply both sides by 3. And this will get rid of this fraction. Okay, now those 3's cancel out. Okay, so now I can go ahead and distribute that through there. I get 20x plus 2 equals, distribute 3 through there, 18x plus 6. Okay, I'm going to subtract the 18x across, which is going to give me 2x equals, and subtract the constant across, gives me 4. So x equals 2. Now notice it didn't say for me, I'll go back and read the directions. It didn't say find x. It says find the length or the distance from J to W. That's this piece right here. So now we have our x. we go ahead and fill it in to right there for the x. Okay, so 6 times 2 is 12, plus 2 is 14. And there's our answer. JW, the length from J to W equals 14. Okay, so again, you set up the relationship and don't multiply through by fractions. Get rid of it, multiply both sides by the common denominator to get rid of the fractions, and then it's a nice easy equation to solve. Okay, and we'll do some more practice with the different types of problems that aren't. These three were actually right from your assignment that you're going to be getting in class here. Okay, so I've done these three for you. We'll practice some other ones as well, more just numbers, so you just get more practice. But remember, the relationship is always the longer piece is 2 times the shorter piece every time. So it's a 2-to-1 relationship. The total distance would have 3 parts, 3x. 2x plus 1x is 3x. So if you want to break it into parts, you can take the whole distance and divide by 3, and that'd be 1 part, and you double that answer to get the second part, if you want to do it that way. Okay, and that will end at 11 minutes.